Hello and welcome to my channel. So today let's look at Leetcode 222, count complete tree nodes. Given the root of a complete binary tree, return the number of the nodes in the tree. So the complete binary tree is the nodes in the last level are as far as possible. In the example, you can see that the last level 4, 5, 6. So there is no node after the 6, but also those nodes are as far as left as possible. And we need to design an algorithm which runs in less than O(n) time complexity. Um, so the first example, for this binary tree, the answer is 6. So because we have 6 nodes in the tree, and the second example, it's a null node, then it's return 0. And the third node, there is only one node in the tree, so return 1. And the number of nodes in the tree is in the range of between 0 and 5 times 10 to the power 4. The tree is guaranteed to be complete. And also the node value is between 0 and 5 times 10 to the power 4. Okay. So for this question, we can design a help function called have the key. We can actually write it here. Has k. So it will be a Boolean function. So what it will do is, for example, in this example 1, if you give k as a 7, this help function should return false. If you give k 7 or higher, like 8, 9, then it should all return false. But if you give 6, 5, 4, 3, 2, you need to return true. So and if we have this function, we can just do a binary search. We can find the first one we doesn't have, which is 7. So we just minus 1 from that value will be the count of the nodes. So yeah, and for this has a k, we can also like search the tree by levels. So yeah, so actually let me so the total in this approach is time complexity will be log n times log n, because of the binary search will be log n, and inside the binary search the has k will be another log n time complexity. So and the space is O(n). So that's actually satisfying the requirement of question asking less than O(n) time complexity. So let's start working on this has k. So we can define a path. Then if the k is in the tree, what will be the path? So for example, if it's a 7, then the path will be from 1, 3, and 7. So we just need to put the data in this path list. So we can do I while I larger than 0. So then we divide I by 2. So until it's becomes 0 and it will break out of this while loop. So yeah, so now the path will, this path will containing like for if we input a 7, the path will have 1. So actually the path will be like a reverse order. So like a 7, 3, and 1. But when we when we iterate, we can go from the end of the list to the beginning. So yeah, so we can. So if the node is null, then it means we need to return false. So which means we actually cannot find a node corresponding to that k value. So otherwise, we can check if the previous I is yeah, actually we need to be I larger than 0 because we are checking I minus 1. So if the previous I is if it's mod 2 is 0, which means we need to go to the left. Else is if it will go to the right. Then in the end, we just need to return if the node is not null, the last node. So if the last node is null, it's also return false. Yeah, so now we have this function. Then we just need to like do a binary search. So the binary search range low is 1. But the high, we actually need to maybe calculate also the depth of the tree. So we define another function called get height. Yeah, so this function is we will get the height of the tree. So we just go to the left. Well, we just go to the left until we reach a null node. So this will give you the height. And so the max so if the height is 3, then the maximum number of nodes in the tree will be 7. So we can define this this height to be the height of to be the math of power of 2 to the power of h. So firstly we get the h. Get h is a get height. Then now we can do the binary search. So if we don't find this mid, then which means we need to search lower range. So we set high is mid. Otherwise, this mid is inside the tree. Then we can do the higher range. So low is mid +1. So in the end, the binary search will converge, and the answer is we need to get is low -1. Yeah. So this first example works, and okay. Yeah. So this conclude today's session. If you have any question, please let me know in the comment. Thank you for watching. See you next time.